Okay, here we want to look at the difference between an algebraic graph and an exponential graph. I'm going to say it again, an algebraic graph and an exponential graph. All right, this is how it looks. So on the left side, we have an algebraic graph. So I'm going to put a few numbers in here. Let's start off with negative 2. Let's go negative 2, negative 1, 0, 1, 2, 3. Just to give, let's go 4, just to give an example. This is algebraic. I'm going to write this up here. Now, 3 times negative 2 is negative 6. So we'll have negative 2 here. 3 times negative 1 is negative 3. 3 times 0, of course, is 0. Now, y'all keep in mind, this is not graph paper, so I tried to draw this as evenly as possible. 3 times 1 is 3. 3 times 2 is 6. So we'll go over 2. 3 times 3 is 9. And 3 times 4 is 12. All right. So basically, our algebraic graph is going to look like this. Now, let's look at our exponential graph. And we'll be able to look and really see a difference. Okay, I'm going to go negative 2, negative 1, 0, 1, 2, and 3, 4 here as well. Okay, 3 to the negative 2, if we remember, that is 1/9. So here at negative 2, it's 1/9. So it's so small, it's basically just a touch above the x-axis. 3 to the negative 1, okay, we'll have it here. That's going to be 1/3. So once again, it's just about a third of the way up. 3 to the 0, like anything to the 0 power, is 1. And now we could, kind of start seeing the difference. 3 to the first power is 3. Now, this is at the same spot. If we look here, 3 times 1 was 3. And 3 to the first power was 3. So we're at the same spot here. But now, let's see what happens to this exponential graph. 3 squared is 9. Okay? 3 times 2 is 6. So you can see now it's outgrowing it. 3 to the third power is 27. So now I can't even put it on my graph. And this is what we mean. I'm just going to put it as high up as I can possibly put it. Yeah, this is what we mean in 3 to the fourth. I'm sorry, that's going to be 81. So now to look at this one, we can see how it just takes off. Okay, so 3 to the times 5 would be 15, but 3 to the 5th power, let me put this right here. 3 times 5 would be 15. but 3 to the 5th power would be 243. So when we hear the term, when we hear that something is growing exponentially, that's a figure of speech to describe how fast something is rising. Okay, it's a figure of speech, but this is what it's based on. So this is the difference between that graph. And guys, this would actually it would basically sit right on there and never cross negative over into the negative numbers. But this is exactly what we mean. We can see how the algebraic graph increases by 3 each time algebraically. But the exponential graph, the graph of the exponential function, it grows very, 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 very rapidly. It increases very rapidly. So like we said before, that's what we mean when we say something is growing exponentially.